Hi guys, good afternoon, good day everyone. Hope you are good. Welcome back once again. I am Ridwan. Okay, look at this. We have already started this calculus course. In the last video, we discussed some concepts about differentiation. So you can watch the video. This is part two of that differential calculus. So we have done some of the differential coefficients of constants of cx raised to power n, etc. like that. So you can just check the video if you have not seen that. So this is the continuation. So let's now continue from where we stopped everybody. Today, we want to discuss differential coefficients of a sum or difference. What do we mean by that? For example, let's say y is given as u plus v. It can be plus, it can be minus, plus or minus v, where u is a function of x and v also is a function of x. In that case, what will be the derivative of y with respect to x? Now, can I say that therefore the y dx will now be equal to the u, you differentiate this one with respect to x dx, plus or minus, as the case may be, dv dx. It's very simple. What does that imply? That is, when you are being given a function in form of addition or subtraction of whether sum or difference of other functions, then the derivative of y with respect to x will be given as this. Now, as simple as this one is, let us now implement it on those examples. Now, let's look at these examples. As usual, we all know that whatever the questions we want to solve, I always keep one for you as a gift. Okay, so that number 5 is going to be your gift, but let us do that 1 to 4 together. Okay, now let us start. So we have this: find the derivative of each of the following: 1, 2, 3, 4, 5. So let's start. Solution to that example: Roman figure 1. As usual, we can say let y to be that function 4x raised to the power of 3 plus 5x raised to the power of 2 plus 3x. Then what are we going to do? We cannot say, okay, the y dx now, can you see, I have 3 terms here. This one is one term, this one is one term, this one is another term. Are you with me? So it will now become, what the rules is just saying is that when you have different functions like this, and the operation in between them is either plus or minus, just differentiate each of them respectively in that order. So this one will now be d dx of 4x raised to power 3. That is, I want to differentiate this guy with respect to x, plus differentiate this one as well with respect to x. Then, are you with me? Then, plus d dx of 3x. Can you see that? Now, what would that be? If I differentiate this one with 12, what would that be? 3 times 4 as usual. If you remember from our formula, 3 times 4, this one power times 4, that's 12. Then subtract 1 from 3, that's 3 minus 1, that's 12x raised to power 2. Beautiful. Plus what? 2 times 5, that's what? 10. Then x raised to power what? 2 minus 1, 1. So x raised to power 1, but you don't need to put it, okay? So just leave it like that. Plus what? Now, 3x. This one will be, the power here is 1. 1 times 3. That is what? 3. Then x raised to power what? 1. Then minus 1. Are you with me? So now be 12x raised to power 2 plus 10x plus 3x raised to power of 0. And don't forget, x raised to power of 0 will be 1, okay? Provided x is not equal to 0. So that's going to be 12x squared plus 10x. So if this one is 1, 1 times 3, that is 3. Wow, that is beautiful. Do we get that, everyone? Very simple. So it's as simple as that, okay? So we are just using that rule because we have sum here all through. We have 3 functions. So that is that. Let's go for number 2. Let's go for number 2. It's very simple and straightforward, mind you. Now, Then I'm on figure 2 now. Let what, as usual, let y to be 2 all over 3 x raised to power 3 plus 6x squared minus 7x plus 3. Guys, let me tell you something. You know, in this case now, I have like what? I have sum, I have difference. Now, we all know that what you're supposed to do is d dx of this plus d dx of this minus d dx of this. But that's very fine, mind you. In theory, you can do it like that, okay? So they will know that, oh, you really understand this thing very well. If it is an objective, you don't have much time, you can do it directly. You don't need to be saying d dx of, if it is an objective, okay? So you can just say, okay, I want to differentiate this one respectively. I want to differentiate this one separately. I will differentiate this one too separately. I will differentiate this one separately. I will differentiate constants. Don't forget, when we differentiate constants, it will be 0. Good. So now let's go. Oh yeah, let us differentiate this. What will it be? 3 times 2 over 3. That's 3 multiplied by 2 all over 3. Then x raised to power what? 3 minus 1. Beautiful. Plus 2 times 6, 12. X raised to power what? 2 minus 1. Beautiful. Minus what? 7 x raised to power what? 1 minus 1, 0. Then plus, when you differentiate constant, this 3 is constant because there's nothing like x here, okay? It will be 0. So, are you with me? Now let's go. 3 will cancel 3. This will now become, we are left with 2. X raised to power 2, right? Plus 12x, because 2 minus 1. Power of what? 2 minus 1. And this one will be what? 1, isn't it? Then minus x raised to power 0 will be 1. 1 times 7 minus 7. So the result is this. Wow! That's lovely, everyone. That's beautiful. Okay? Now let's go. That's Roman figure 2. Now Roman figure 3. What do we have, everybody? Let what? Let y to be 7x raised to power 3 plus 5x squared plus 4. Okay? Now let's go. The y dx will be what? If you just do it directly. Very simple. That's what? Differentiate this one with respect to x. That's 3 times 7. 21x raised to power what? Remove 1 from here. That's 2. Plus, differentiate this one with respect to x as well. 2 times 5. That's what? 10. Then x raised to power 2 minus 1. That's what? 1. So, but you don't need to put it there. Just leave it like 10x. It still needs power 1. Plus, when you differentiate constants that does not have any x, any variable x or any other variable, that's what? That's going to be 0. So the result will now be 21x raised to power 2 plus 10x. Are you with me? Wow, that is lovely, everyone. That's beautiful. Finally, Roman figure 4. Let's look at that. So we have this. Let what? Let y to be x raised to power 2 plus 1 all over x squared. Now, just like what we did in the previous video, whenever we have been given something like this, don't just jump into finding the y dx. You have to find a way to rewrite this thing. This one, x raised to power 2, is okay. But look at this 1 over x squared. We have to rewrite it in form of cs raised to power n, so that it will be easier for us to do what? To find the derivative. What do I mean? I can say y is, that means you have to find you have to simplify this one first. So now be x squared plus, you know, from the law of indices, how can I write 1 over x squared? I can write it as x raised to power minus 2. Wow, that's lovely. Now it is beautiful. Now I have this power here, I have 1 as coefficient, I have power minus 2, I have 1 as coefficient. So I can now say the y, the x, I can now differentiate. 2 times 1, 2. Then x raised to power what? 2 minus 1, 1. You leave it, beautiful. Plus, minus, you know, coefficient here is 1 as well. Minus 2 times 1. So you have to put, because of this minus, you have to put the bracket, plus into bracket, minus 2, x raised to power minus 2 minus 1. Don't forget, you have to subtract 1 from the power. That's the rule, okay? This one will now become 2x plus times minus, then 2, then x raised to power minus 2 minus 1, minus 3. Okay? This one will now become 2x minus 2 multiplied by, I can rewrite x raised to power minus 3 from the law of indices as 1 over x raised to power of 3. Wow, that's lovely. So it will now become 2x minus 2 times 1, that's minus 2 divided by x raised to the power of 3. Wow, that is lovely. Are you with me? Good of you. Beautiful. So we are done for today, everyone. So don't forget your gift. This is a very beautiful gift for you. And please don't forget, kindly subscribe, share, and like so that because this we continue. Don't forget, we have a lot of things to do under differentiation though. So we still have the composite function, we have implicit function, we have parametric function. So and we have so many. We are still going to trigonometry, all those sine, cos, tangent, sine, cos. That's for the hyperbolic. We do everything, okay? But let's be doing it little by little. Take care. Make sure you do the that very beautiful gift. All right. See you. Bye.